Well, good morning, everybody. I'm going to start you off with a map on the last 72 hours of snowfall. And this was through 7 o'clock last night, Eastern Time. And I'm looking specifically at a couple of these areas that have added quite a bit just lately. I'm talking about parts of New England. We had the system that rolled through late last week into the weekend that came through the upper Midwest. And then some of the snows that were coming down the kind of the spine of the Rockies in through here. We can also see the additional snowfall that hit parts of the Pacific Northwest. Now, a couple of areas that need filling in with this snowfall as we approach winter. That's one of the big topics we're going to get into, but I do want to show you, it's kind of neat. Yesterday on satellite, you could see, let me take you back here, that kind of when some of the clouds cleared out, just how much snow was in parts of North Dakota, getting into parts of Saskatchewan and Manitoba here. Just kind of neat to see that. I always like to look for this kind of stuff. But this whole pattern is in a bit of a transitional mode right now. And as we watch the next big features take shape, I wanted to show you some useful tools that you could play around with if you'd like to, and then also do a bit of a model comparison. Actually, for the rest of this whole thing, I want to be comparing models. So let's go in here and look at this. Told you first a little bit of context on that snowfall. I make these maps every day. There's season to date total snowfall, and the data come from NOAA. And what you're looking at here is on my color bar, just look for this break right here. That's where you get over a foot. And as we look at this, we notice that parts of North Dakota have already exceeded a foot in snow. And what's interesting is that snow I just showed you right underneath this cloud cover here. This isn't going to last long. A lot of this is going to melt. Sorry, it's got a new scan in, so let me take it back and show it again. And when that snow begins to melt, it's really going to work in a very positive way for the soil moisture issues that still sit throughout a lot of the plains. But again, this is our season-to-date snowfall total through yesterday morning. I'll get it updated this about 9 o'clock this morning. And I also want to show it to you compared to average. So this is a percent of normal. So we're just trying to identify those places that have and have not seen big snows so far this year. So this is kind of just a good look at what it looks like across the country. Now, where is this map going to be making some big changes? In the very near term, it's going to be part of the high plains, right down in through here. And then later, once the jet extension really starts to manifest itself after around Christmas, we're going to start talking about bigger snows in the Sierra Nevada mountains as well. But a lot of the rest of the country is left out of the flow in the near term. This is a very, this is just an interesting El Nino-like pattern that we're in. And we just need to discuss when and where we're going to be seeing these chances of precipitation come back up. So I keep mentioning the snow that's coming. Let's go ahead and have a look at it. This is this morning's 0Z high resolution run from the European model. And you notice that high over low system we're talking about. So remember, the ridge goes over the top. That's what's bringing in the heat that's going to melt the snow in North Dakota. But there's this cutoff low that's underneath it that's going to slide through parts of the high plains here. So parts of New Mexico, Colorado, Texas and Oklahoma, even southeastern Kansas, we can start to see that there's going to be some locally very heavy snowfall. And take a look right in through here, this part of New Mexico, there's the chance of getting several inches of snow, 8 to 10 inches of snow is possible. So I'll just play this on out, and why don't we just go out 5 days, all the way till next Saturday night, and we can start to see some of that heavy snow may move into, some pretty productive cotton acres, wheat, corn, soy. There are a lot of stuff in the panhandle of Texas. So there you go. That's kind of our near-term setup. And to be honest with you, that's kind of the main system we'll talk about all week until we get this jet extension. Now, context for all of this. This is an area that's been really dry. All right. You can also see this dryness that extends, clips a big section of Texas here, Oklahoma, this corner of Kansas, and then stretches right on through the Mid-South, up into parts of the Midwest. And speaking of the Midwest, the upper Midwest, the parts of South Dakota, dry, and Montana dry. There's these holes that have yet to be filled in with precipitation. And a big one is California is waiting on the start of its wet season as well. And I bring this up, and I read all of your comments every day. I apologize. Sometimes I just don't get a chance to respond to all of them. I love reading them. I think it's just fantastic to hear your feedback. And there's been a lot of discussion lately about how dry things have been in just certain pockets of the country. And I'm going to show you a tool that I want you to play around with and use. It's NOAA's Climate at a Glance tool. So literally, I'll link this in the notes below, but if you go to if you just even Google Climate at a Glance, NOAA, you can choose across the top a different geographical region you want to look at. Now, I'm going to pick the regional view versus the state, division, county, or even a city. And what I'm going to play around with is the time series. So I've clicked here and here. And what I've set this up is these are all drop-down menus. I'm going to look at precipitation. I want to look at a 12-month time scale. You can choose 1 month. You can choose whatever you want. But I'm going to choose a year-long time scale ending in December. I want as much data as they've got, so 1895 to present. And I don't know, let's choose the Great Plains first. Now, I also went over here and I said, please give me a trend. I want it to be displayed per decade, not per century. And I want it to go from 1970 to 2023. So I'll click plot, and it will make the new time series for me at the bottom. So what's interesting about this is that since 1970, that blue line represents there's actually a slight increase since 1970 in total precipitation for the whole year. And by the way, we all know this, right? Whenever we do these linear trends, it's all dependent on when you start your trend line. I mean, if I started it in the last couple of years, it'd be way down, right? Because we came off with some very wet years like 15, even 16 and 17 were above average, 18, 19, these were all wet years. And then the last 3 years have been very dry. And so you can see the difference. So I try to go for a longer trend of greater than 50 years here just to see what it looked like. So this is just a great way to kind of analyze it. You can do anything you want, go anywhere in the country you want, change your time scale around. I don't know, if you're interested in the Corn Belt, let's click on that and just see annual precipitation for the Corn Belt. Also up quite a bit here over the Corn Belt for the whole year. So I want you to play around with this tool, and I want you to do one other thing after you're done with it. There's another great way to assess, drought, and that is just to go to the drought monitor. Now, there's lots of great tools on the drought monitor. I'm going to show you 2 of them real quickly today. So when you get here, slide across the top and go to Data and click on Time Series. Since we were interested, by the way, this goes from the year 2000 to present. Every drought monitor showing you the area of the geographical region you're interested in that was under drought. So I chose national to start. But I can come in here and say, well, let's do this. Let's break this down by geographical regions. In fact, let's go by state. Why not? And I'm just going to pick, I don't know. Let's pick Kansas. I landed on it. Let's just go there. So as we look at Kansas, over this time period, we can see these episodes of drought that have set up, and we can start to analyze, what's caused these droughts. Is it helped along by El Nino, La Nina? What was the ocean pattern doing in the North Pacific, North Atlantic? All of these things are tools at our disposal, and you can see here that really since, 2020, we've had a pretty long-standing episode of developing and redeveloping drought in Kansas. The second thing I want you to do with this is you can also come over here to this tab called Ag and Drought. And what it'll open is just a whole new view of the drought monitor. I like going to the row crops. It'll even tell me what part of each crop is currently in drought. And then you can even come down to the bottom and say, well, just make me a map of it. And I'm curious about, winter wheat. And it'll show you that. So let's shrink that up so you can see it. That right now, 38% of the winter wheat crops are in some form of drought. And it shows you those winter wheat acres according to the USDA and where it overlays. So if you want to play around with this, please do it. I think it's just a great tool and helps us to kind of understand and monitor this stuff. And my goal is always to just empower you to do this work yourself. So given all of that as a backdrop, let's get back into this story. Because over the next 7 days, while we wait on the Pacific Jet to extend, we do have a cutoff low that's sitting off the coast here that might bring in some scattered precipitation, but most of the rest of the west, including the mountains, are dry. We have this cutoff low, I'll show it to you in a few seconds, that's underneath a ridge that the new European model is dipping pretty far to the south. And why am I telling you this is because compared to yesterday, this whole region went much drier as the evolution of the pattern and the European operational just steals the moisture for this area. And I'll show you how it does it in a few seconds. It then does run up the coast, but look at this. This is the European model 7-day precipitation anomaly figure. This is the GFS. Much wetter along the Gulf Coast and East Coast, but very similar in other places, like here in the Midwest, Mid-South, Plains, Prairie, and back into the West. So thinking about all of that, I just want to combine a couple of forecasts for you in two different ways. First, we're going to look at the upper level height pattern from this morning's operational GFS and the European. Now, I always call this morning's model, even though it's 0Z. That was actually technically run at midnight in Greenwich, England, but we're 6 hours off of that central time zone right now. So this was last night's model, but we don't get it until the very early morning. That's why I consider it that. So as I play this forward, I want you to see the high or low cutoff. It doesn't matter which one I look at. There is the ridge, the high, and there's the cutoff low underneath, and it's pretty well established in both models. In fact, playing this out just 36 hours, these two maps match each other almost identical. So GFS left, European right. As I play it forward, though, we get a little bit of a different view of this little clipper that's sneaking through the pattern here in the European, and it's somewhere in this area in the GFS as well. But as I go from Friday, we're already Friday by the way, noon, into this weekend, you see the difference is the strength in this little cutoff. This little closed low here. What this is doing, all right, is as this comes over the top in this direction, it is going to be bringing in on the backside with it some drier air. And the wave that's out ahead of it, this trough in through here, is much farther to the south. Now, the same short wave as here is sitting right over this part of Kansas, but nowhere near as deep as it is in the European. So that southerly wave down here is surviving the trip closer to the Gulf Coast in the operational GFS model. And so what's happening here is this is just changing entirely the timing and amount of precipitation with this trough that's sitting here in the southeast in the GFS versus the European, which brings in this kind of drier system here, forcing the main wave to stay south. And the difference here is just remarkable in total precipitation. But the only thing the models agree on is the snow coming out of the high plains, which we took a brief look at. I'll give you more information on that in a second. What both models attempt to do, though, is take this system at some point early next week and start to pull it up the coast, with the European model being the more aggressive and early in that regard. And we're going to have to watch to see how this system, as it rolls up the East Coast, interacts with a broader trough that's coming out of the Hudson Bay. Notice the GFS has it here completely separate from the trough in the Hudson Bay, whereas the European model connect the two. That's only 1 week out. Here's the pesky low that's just hanging out off the coast of California during this time period as well. And if you noticed, if you're in the midsection of the country, the ridging just keeps coming back. So there's mild air in there, and I know you all know what I'm going to say next. Northwest flow is convergent, and that's why we get drier air just continuing to plummet into the midsection of the country out of the Canadian prairie. But the big problems in this pattern, I call them problems because I want to see this break away, is just this persistent troughing coming out of the Bering Sea, getting into Alaska, and we need to see that whole pattern shift around before we get a different flavor of this, whole setup with the weather. So how about we look at what the models then did with that? So let's see here. This is through Wednesday, getting into, there it is. There's Thursday morning, Thursday afternoon, and evening. So this is when the flow goes over the top, the cutoff flow sits here. It's in both models, pretty well resolved. Now we're going to see these other two pieces, or these two main pieces coming together. So here we are Thursday, 6 p.m., playing into Friday. Finally, that system, which started on Wednesday, starts to move east. Good timing here in both the models so far by Friday morning. Getting into Friday afternoon and evening, playing forward. Now look, here's the system much deeper in the European, and just kind of a weak frontal boundary here in the GFS. So the difference is this. That system interacting with the trough to the south are suppressing the precipitation along the Gulf Coast. Not the case in the GFS. And what happens is the system curls up. Look at how quickly, watch this. Watch this system roll up the East Coast in the European and not in the GFS. See how quickly that does that? Whereas the GFS just opens a broader wave in through here. What's the difference? Snow. Draws in enough cold air for some snow on the backside. And a much more rapid ascent along the East Coast of the United States. So that's out a week in the forecast. And remember, we're going to have to wait beyond that before something finally comes into the West Coast to give us a new look at this pattern. So what do we end up getting out of it? Total precipitation from the ECMWF. Here's kind of that whole package of shortwave troughs. There's 1 week. Here's the here's the GFS. Watch the Gulf Coast right here. So much more precipitation. So we compare the two and you end up getting this. The European model would be wetter in these colors. The GFS is wetter in these. And look at how much wetter the GFS is right now for this area. Whereas the European, with that other wave, wetter here and more snow on the backside. European taking the system up the East Coast, wetter in that area. It's just kind of neat to look at the differences between these models. Now, how have the models been doing? Well, right now, both models are performing or initialized at about the same skill score. Lately, the GFS dropped back off just a little bit. But I'll tell you something, I don't have it graphed here, but the guy who makes this, Ryan Maui, brilliant scientist, love his work. He has been also looking at a copy of the Graphcast model, and it has been outperforming all of this and very steady for a while. Now it's designed to minimize error, so that's what it does. But I want to show you what it's up to. This is its forecast, the newest one from the 0Z run, for the next 7 days of total accumulated precip. Now, I haven't been showing it to you too much because I find it difficult to kind of compare to my other models because it's not the same colors, projection, anything like that. But just take note that the machine learning version of our forecast, while it's big on this high plains event here, it is drier in the southeast. So it makes you wonder, is the GFS really the drier model? We have another way of analyzing this. We just have a look here at probability maps. This is the GFS ensemble probability through the next 10 days of getting an inch. So we know it starts here, but just notice how much wetter this is going to be in parts of the southeast compared to the European ensemble. So we just kind of drop those values off in this particular area. So we're trying to make this assessment on on where that system is going to go based on the ensembles. Now, I could continue to show you all the ensemble members and what it's doing, but the probability graphs, I think, give us the best clue with a quick snapshot. I do want to show you who's going to be drier in this pattern. So this is who's has the best chance at seeing less than a ½ inch, and that is a large area of North America that is left out of the kind of flow that I want. Now, what is that again? We're getting flow at times that does this, and currently, right now, is kind of got a cutoff low here, so we're not getting the great flow into the west. We don't like northwest flow except for summer. So what needs to change? The flow's got to come in like this. If it starts coming in out of the southwest, the whole pattern lights up, and we get system after system after system. That's the bigger picture of what we're waiting on. Now, I mentioned we'll give you some more info on the snow, so I thought we'd go in here and look at the probability of getting an inch of snow in the next 10 days. So highest right here, Colorado and Mexico, the panhandles in this part of Kansas. Who's getting more than that? There's the chance at 3 inches. 3 inches. Here's the chance at 6, and here's the chance at over a foot. We're going to watch this part of New Mexico pretty carefully. Okay, from here, we are still waiting for around Christmas to see the full extension of this jet. If you're curious, that's about 6,000 miles. Now, if we link it all together, starting here, and then coming across Japan out into the open ocean, and then maybe include this piece of the subtropical jet before things kind of split over here. If we want to call this one continuous piece, this is bordering on about 18 to 20,000 miles of extended jet position. It's kind of a rare event, but if this continues to take place, like we're suggesting here, the models out there at week 2 are starting to pick up on what this is going to do. It all depends on where it enters the U.S. The current thinking is somewhere in California. That's why all 3 models have gone over wetter in week 2. But why we're not seeing yet any sort of shift across the rest of the country to more active weather is because we're getting a split on the other side. Can you see that? So where do we get? Northwest flow. This just kind of ruins the rest of North America for good systems based upon this. But it is something that's changing. It's going to invigorate the pattern, and it's going to be important to watch. Now, what I'm putting all of this kind of wrapped back up into the context of, since we started with the drought monitor, is what's happened since October 1. So this is October 1st to December the 11th. Now, that's a long time period over which to look at these statistics, but again, I'm thinking a lot about this area still having yet to bring in precip, and then we're seeing really dry conditions in through this area as well. And I understand you're like, no, wait, we just had a bunch of rain, a severe weather outbreak. You did. But remember, this whole pocket of the Mid-South, Midwest, Ohio Valley to the Appalachian Mountains, pockets throughout the plains, the Southwest, this is the area that just continues to show up, in our drought situation that we're waiting on corrective action for. Sorry, I thought I clicked on that. There it goes. So I just wanted to add that context to everything. Okay, temperature-wise, we have freeze warning, in California's Central Valley. We've actually seen the National Weather Service put out the winter storm watch in place here already, getting prepared for this next system that's coming through. We still have some cold air down here in the southeast and Georgia and Florida. And finally, we're getting the systems out in New England. So let's talk about those temperatures. I told you that snow is going to melt. Watch this. Here's Tuesday's highs. Getting into Wednesday and Thursday, of course, because I'm going back up here to Minnesota and South Dakota. I brought the warm weather with me. I will be bringing a coat. That's a little too chilly for me, despite it being 15 to 20 degrees warmer than average. By Friday, getting into Saturday and Sunday, the only cold spot is where that system's going to crank out on Wednesday, Thursday, where the snow is. And that's just about it. Very mild air coming in overall. Now, since we spent some time earlier doing a model comparison, let's just do that with temperatures. I make these maps on agweather.com. I'm working on the ensemble maps from the European model. Just need a little bit of time to finish that coding. Here's your next 5 days, day 5 through 10, and day 10 through 15, which takes you right up to Christmas. Very, very mild week surrounding Christmas right now for much of the country. That is echoed in the GFS, in the European model, but I've been giving you this view of the European model because I want to talk just briefly about where this cold air is going. There's the next 5 days. There's day 5 through 10 where it translates south and east. So this is now getting over into parts of China, Southeast Asia. We then play it beyond that, and it almost appears that it just goes away. That colder air is still sitting somewhere here. It is part of the Arctic, the Bering Sea, far eastern Asia. But a major swing in temperatures is happening for Siberia and Russia. At the same time, both of these areas are very mild, and one of them is going to have to make a pivot, a turn, I think, at some point. It's just not going to be until January, and I don't have any strong evidence for that. The thing I'm watching most carefully is this. This might be the biggest piece of the tropics we need to keep an eye on. Most model forecasts have been sweeping the MJO way over here to phase 8 and 1, and now there's a lot of evidence that's going to stall weakly just out of null space in phase 6 and 7. Now, there's a lot that means, okay? First of all, the move to 6-7 does help the jet extension. I would have loved it if it kept coming over to phase 8 and 1. That would have really pushed the jet all the way across the Pacific and hit the United States. Instead, if we stall out right in this area, that's a very weak tropical teleconnection. It's very telling of the fact that there is an El Nino. It's there. It's influencing the pattern, but it didn't get the chance to push the convection farther and farther to the east, which is what sometimes El Ninos do. So who this is really going to affect is going to be South America. And my narrative is almost the same as yesterday. Heavy rains, which are desperately needed in parts of Argentina, not along the Paraná River, but here, this is going to be a huge thing for Argentina. But we have better than 90, maybe 95% of Brazil's growing area right now under drier than normal conditions. And it is, as we've been doing all day today, it's in both models. It's the same outlook overall. Now, here's what I'm concerned about with that MJO transition. It made it to about right there, okay, just in general. And if we could push this farther to the east, this rising motion here would start to slide over. And instead, we have suppression right in this area. So there's basically sinking motion here and rising motion here. And that's kind of how the tropics breathe. So without the MJO opening up and moving a bit farther, just a bigger area of rising motion, it's going to be difficult to get the precipitation to kind of get back into northern Brazil. Now, please watch this carefully. This is the newest forecast for December 21 to 28. All right. I've been showing this for the last couple of weeks, but I want to show you what it said a couple of weeks ago. Let's just go back to the run on, how about a week ago? Look how much wetter it was for that time period. In fact, we even go back farther than that. Very wet for this go. So the newest models have just continued to trend drier. And I think it's the failure on the MJO advancement that's helping guide this. Now, we still have our other issues, like the positive phase of the Atlantic meridional mode. That's been the thing that's kind of ruined the flow, bringing it at times more in like this. We talked about that all earlier this season. El Nino, we know that El Ninos tend to be drier at the start of the growing season here and wetter farther to the south. So those are the background factors. We're just looking at the individual factors as we press through each week. Now, I mentioned El Nino, and I think we should just kind of finish up with that. El Nino right now is probably at its peak. Notice that over the last, let's go to here, that over the last couple of weeks, we've just kind of flatlined. It's 1.5 degrees C above average. So are we going to continue to get more development of it? I made a case yesterday with the negative PMN, that's the cold water there, the negative PDO, the cold water here, plus the cold water coming off of this side of South America. Where is the additional support from both hemispheres to pull this along the equator in a stronger and stronger mode? And even though there's still some warm water to upwell here, I don't know that's that much warmer than what we've already got. So I would make the case that we are plateaued. I think the El Nino will stick around this strong for maybe 3 to 6 weeks before it starts to back off in the rest of winter. But I'm curious about this negative PDO, and here's the reason why. I flashed this map a minute ago. I've seen some evidence that, and again, over the last week, we're getting a little bit of cooling in this area. And if we keep this deeper trough overlast, we're going to get more of that cooling. Now, why is that all important? It's important because historically, if you look at January to March, this is what ends up happening if the PDO dominates. Now remember, we have a negative PDO right now, which means these colors represent, I'll put a W on it, wetter, and these represent drier. Now, if El Nino dominated, the blue would be where we'd expect drier. So the big questions are, January to March, if we get some sort of blend in this, do we end up actually bringing better precip into that really dry area that's already here, or in the northern plains, upper Midwest, or in the Pacific Northwest? And you know that I've been very concerned about next spring, the Great Plains risking drier as well, especially the high plains. I mentioned that yesterday. If that PDO becomes the more dominant signal as El Nino dies, then this has got me worried. Now, I'm going to have to watch this very carefully. Because if El Nino dominates, then it's wet in California, it's wet across the south, it's all the way down here. It's drier here, a little bit drier there, and drier in the northwest. So you see, we've got this competing factor between the North Pacific and South Pacific, well, the North Pacific, and the Equatorial Pacific. That's going to continue to warrant attention. So in between some longer range updates, that's kind of what I wanted to feed you here. And I hope you enjoyed today's video, and we'll talk again tomorrow. Thanks.